The Sydney Metro project is Australia's largest public transport project to date. The project will deliver 31 metro stations and 66 kilometres of new metro rail in Sydney, with the goal to revolutionise Sydney transportation. From Chatswood to Bankstown, the metro will run in newly constructed tunnels under Sydney Harbour through new underground stations in the CBD and extend beyond to the southwest. After completion, the metro will have an ultimate capacity of approximately 46,000 transport goers per hour, with the ability to run trains every 2 minutes in both directions through Sydney City. This makes it an increase of up to 60% capacity across the metro network. Sydney Metro consists of two key stages. Now completed Stage 1, Sydney Metro North West, and Stage 2, Sydney Metro City and South West, which is due to open 2024. For the purpose of this presentation, I will focus on the three parts of Victoria Cross Station, Barangaroo Station, and the connecting twin tunnels between the two stations. Here I will discuss the project scope, key assumptions made, and provide a quick overview of the risk management approach from a general design and contractor perspective. With the large amounts of uncertainty that inevitably comes with large infrastructure projects, it is pivotal to understand, take, as well as to manage risk comprehensively. So the big question is, how can we make the project risk resilient? With a robust and clearly defined risk management procedure, good governance and controls, companies can prepare themselves against any external risks and can be prepared to adopt and absorb disruption were that risk to eventuate. The adopted risk assessment approach for the identification and analysis of potential risks for the metro scope is consistent with the Australian Risk Management Standard. Before any risk management or assessment occurs, it is paramount to establish the external, internal, and risk management context that could be a source of uncertainty. This is because risks can then be identified more readily. For a start, let's take a quick look at the scope and objectives for the project's risk management process and identify a couple of significant factors in the external environment that raise uncertainty. The Barangaroo station site is situated in Hickson Road and is part of the Barangaroo Headland site. The site will be used to complete the following construction activities, including launching and supporting the specially designed tunnel boring machine under Sydney Harbour through the Blues Point temporary site, the excavation and construction of future Barangaroo Metro Station, the excavation and construction of a large crossover cavern, as well as barging approximately 2.4 million cubic metres of spoil. Victoria Cross Metro Station comprises of two areas on Miller Street, North Sydney. The Metro Station is inclusive of a station cavern, north and south entrances, as well as the south concourse and ticketing facilities. Victoria Cross North is located at the corner of McLaren and Miller Streets, and Victoria Cross South is situated at the corner of Berry and Miller Street. To complete the Victoria Cross Station, the main construction activities required will include tunnelling and cross-passage works, utility works including a stormwater upgrade, detail excavation at the base of station shafts, construction of the north, south and overstation development structure including erection and dismantling of formwork and concrete works, facade installation, internal fit-out, and public domain works including footpaths and landscaping. Metro Barangaroo will be excavated from the surface following a cut and cover construction method. On the other hand, the Victoria Cross Station caverns will be mined from underground. Assumptions play an essential role in developing a risk management plan. I have made the following assumptions in the preparation of this assignment. It is assumed there are potential contaminants in the existing buildings on the sites as well as within the seafloor in Sydney. It is also assumed that the selection of the specific tunnel boring machine was made appropriately for the ground conditions. And lastly, it is assumed that in selecting the sites for the metro stations that heritage considerations were assessed. A comprehensive risk identification process will be followed to develop an exhaustive list of risks and events that can possibly impact the achievement of the project's objectives. The approach to risk identification is influenced by the nature of activities mentioned above as well as the organisation's context. To identify risks and events specific to the metro scope of works, the following tools will be implemented. Checklists, assessment of the existing environmental conditions within the Victoria Cross to Barangaroo area, judgments based on experience and records, for example other infrastructure projects including the North West Metro project, facilitated risk workshops as well as geotechnical reports, just to name a few tools. Using these various tools will enable the project team to be aware of all risks and be prepared to adopt and absorb disruption should a risk occur. Some top risks identified include traffic and transport, contamination, tunnel collapse, flooding, as well as heritage. Let's quickly discuss why. Both station sites are located in highly trafficked CBD environments as well as high-density urban and commercial precincts. Construction activities will be conducted alongside popular destinations and will have a diverse range of neighbours that include residents, businesses and schools. Investigations into the sediments in Sydney Harbour have found large areas of sediments are polluted by metals and a range of non-metallic contaminants. These contaminants could be encountered during the required excavation and tunnel boring. Evidence of Aboriginal occupation in New South Wales dates back to around 50 to 60,000 years ago. Therefore, heritage must be fully considered to ensure project resilience. Archaeological potential for Aboriginal objects have been identified within the western portion of Barangaroo Station. There is a moderate to high chance that Aboriginal objects will be present in subsurface contexts, specifically areas that have not seen a great disturbance by subsurface impacts. Potential for intact Aboriginal archaeological deposits have been identified during preliminary geotechnical investigations. Disturbed archaeological findings could result in a significant and unrecoverable impact on the project schedule. For these risks and plenty of others to be appropriately controlled and avoided where possible, the consequences of identified risks must be considered were they to eventuate. Risk analysis is conducted following the below steps. First, we need to identify consequences for each potential risk using a predetermined consequence table. Second, using the likelihood table, the accountable team members can determine the magnitude of the risk consequences and its likelihood in order to calculate the level of risk. From here, risk is ready to be evaluated in order to determine whether risk treatment is necessary. The level of risk can be visualized in the risk matrix. Here, decisions can be made whether each risk falls within the company's risk criteria and which residual risks will be accepted or will need certain resource allocation for treatment. High priority risks identified must be escalated to the executive management. To treat risks, an organisation can choose to avoid the risk by not pursuing the activity in question. For example, this could be an adoption of a different form of tunnelling method. They could mitigate the risk by establishing preventative measures which reduces the risk, likelihood and consequence. They could transfer the risk to another party or choose to accept the risk without any risk controls. This may be done where there is nothing that can be practically done to mitigate risk. Details of the identified risks, hazards and aspects will be entered into the risk register along with the risk rating and control measures. When working on such a complex project with numerous stakeholders, communication and consultation will be a continual and iterative process conducted with the purpose to provide, share information and to engage in dialogue with stakeholders regarding the management of risk across the Metro projects. Further, due to the rapidly changing construction context of the Metro project, ongoing review and monitoring of risk is essential to enable a proactive response to risk and to ensure the risk management plan remains relevant. Having a correct understanding of risk and ensuring risk remains within the selected risk criteria is crucial for project success. Any actions or events that change the status of a risk must be documented. Contingency management must also be integrated within the risk management process. Contingency provisions are cost allocations within a budget to protect the costs of unplanned activities or risks that are unavoidable to deliver project outcomes and require additional funds. Lastly, each stage of the risk management process must be documented appropriately. During the process, any assumptions made, methods, data sources, data analysis, results and decision making should all be recorded within the information management system. To conclude, a comprehensive approach to risk management would address the key issues facing all parties and stakeholders throughout the Southwest and City Metro project. For effective risk-informed project management, a company must define a comprehensive conceptual risk framework, a strong set of practical tools and approaches to assist proactive risk management, and ensure risk management is continuous across the entire life cycle of the project. At the end of the day, residual risks of the Metro project can be managed and would not result in any long-term detrimental or irreversible complications, subject to following the recommended risk management process discussed. The project's ability to respond to Sydney's forecast population, economic growth, and address emerging constraints on the existing rail network outweighs the potential risk impacts associated with the metro's construction.